Okay, so hello everyone. This is Weilu. I'm a new assistant professor in the Department of Electrical Computer Engineering, and I'm starting my lab. And for sure, I'm looking for the best students to join my lab. So my research is about, in the very broad sense, to study the light and matter interaction at the nanoscale. So we are engineers and scientists and try to design the better photonics, optoelectronic devices using the weird nanotechnology, I would say. So yeah, we are aiming to using photonics to design the better devices for the computing, for the communication, and for the quantum technology, and for the health application as well. So first, I would like to echo what Florian have ever said about the multidisciplinary nature of the research in electrical and computer engineering. So before joining the U, I have been working in the startup company, designing the photonic devices for the AI accelerators. So where I have been working with a team of 10 scientists of engineering from a very diverse background. I have been working with the physicists studying the dark matters, the physicists studying the computer, quantum chemistry, and the digital designers and the physical designers and analog designers and packaging engineers. So you can also see that this type of multidisciplinary research has been reflected in the many research here in the many groups. So for me, I have been focusing on the three aspects of my research. The first is about reconfigurable photonics. So in this area, we'll study the materials and use new materials to design devices and build systems out of that for the optical computing and artificial intelligence. And with the evaluation of systems, we can further optimize the materials and devices. So this closed loop style can really build the high performance, the hardware accelerators for the AI. And my second research area focused on the ultra strong coupling physics between the light and the matter. So more specifically, I will study the exciton physics in the nanomaterials when it is coupled to the photons in the cavities. So the properties I'm looking at is the ground state properties of these materials. So when you put the materials inside the cavity, how the fundamental properties of these materials will change so that you can build a better and new devices out of that, and which can find applications in quantum optics and quantum chemistry by designing the cavities and the materials. So the third area I'm working on right now is the terahertz sensing. So by designing the better and new technology using the AI and the quantum technology, so I'm aiming to design the better and ultra sensitive sensors in the terahertz for the bio and chemical molecule detections. So if you want to know more details, you can go to my group website. And if you're interested in any of areas you want to know more about my research, you can feel free to email me. And I said I'm looking for the best students to join my lab. So just feel free to email me if you have any questions. Thanks.